here in part 2, or in video 2, I suppose, I'm going to be talking about accuracy and precision. So these are words that we often use pretty interchangeably in everyday life, right? We use the word accuracy often to mean essentially that someone got really close to something, you know? And saying that, well, you know, that we want to be really precise means that we want to be really close to whatever it is that we're trying to say. Well, in chemistry, and in a lot of scientific contexts, these words are going to have a little bit more specific meaning. And it can be a little bit nuanced here, but I'll give you some examples that I hope will make this make sense. So when we say accuracy, what we usually mean by this is how close are we to the target? Whatever the target is here. So what we might say is, how close are we to the target? Can't talk and write at the same time very well. How close are we to the target? But also, right, how close to the corrected value, whatever that might be. It's all right to the quote unquote true or correct value. Okay, so one way we might think of this in a scientific context is say that you have a sample of matter. Say you got a chunk of steel, and you know technically what the mass of it is. Maybe the manufacturer has said, hey, we've massed this on 100 different scales, and we know for certain that this is 100 grams of steel. All right, so let's make ourselves a little steel cylinder over here, right? So we've got this. We'll come down here. Gotta make it look nice, you know. And I will just hand draw an ugly bottom here, right? I gotta close this off because I'm gonna paste some stuff in here. So we've got this little chunk of metal, and we know that, at least in theory, this thing is supposed to weigh, I'm going to use weigh, even though it's not really, we're not talking about weight, but mass. But let's just say this, we know this is supposed to weigh 100 grams. Okay? But when we mass it, that looks like when me mass it. Yeah, I'm not really used to writing with this tablet, as you might have seen. But we'll get there, right? It's all a process. So when we mass it, what we see is 99.7 grams. And then we mass it on another scale. Right? And let's say we also get 99.7 grams, right? What we might talk about here is, well, what's the true value supposed to be? We could call into question, did the manufacturer mass this accurately? We're going to say accurately because what we're calling into question right now is, what is the actual mass of this object? How much mass does this object contain? If we measure it repeatedly and what we get is 99.7 every time, well, what we might be able to say there is that 100 grams is not an accurate measurement of the mass of this thing. Now, if we got that from the manufacturer and we massed it on one scale, right? So let's say, let's do this. I'm going to draw a little divider in for us here, and we'll label these as different cases. So, case 1. Let's call this manufacturer is inaccurate. Okay, and we're going to say that, right, because although hypothetically, we only took these two measurements, let's say that we took a bunch of measurements, and every one of our scales all say 99.7, right? So now let's look at another case, right? What if we're the ones who are inaccurate here? One way that might look is one of our scales is inaccurate. So I will go up to here and we'll say on scale 1, right, maybe we get 92.1 grams, way off from 100 grams, right? But then on scale 2, we get 99.3. On scale 3, we measure this, and we get 99.7. And then just for fun, we measure it on one more, right? So on scale 4, we measure it, and we get 100.1 grams. Well, let's look at these measurements. 3 of these are pretty darn close to 100, right? They're not exactly there. Maybe there's some error on our scale, which is more likely. What I mean by that is that it's very likely that any scale has a little bit of error to it. We calibrate it to minimize that error, but it still will have some finite amount. But scale 1 gives this value that's way lower, right? So if I come up here and I say, we've got this value here, this one's very low. So what we might be able to say here is this scale specifically is inaccurate. And again, what we mean by saying inaccurate is that it's not very close to the quote-unquote true value. These other ones, you know, they're close to each other. And that's a topic called precision that we're going to get to in just a sec. But these other 3 happen to be both close to each other and to the true value. But this other one, this scale 1, wow, that value is really off seemingly. Okay, so this is a little bit about accuracy. We might even be able to say scales 2, 3, and 4 all seem pretty accurate. So let's come in here and say these all seem pretty accurate. So that's topic 1 here, is accuracy. And after we finish up with this, I'd like to come in and show a few images that will hopefully make this, hopefully lock in these ideas, some nice intuitive pictures. But I want to define precision first so we can be ready when we go over there. So as you might have gotten from what we just talked about, precision is how close our measurements are to each other. In other words, how consistent are we? And in fact, I might write consistent or replicable. Okay, so let's bring back our little stainless steel friend here. And what we're going to say is, let's pick a new color. Okay, so case 1, we're going to say, in case 1, we're pretty precise. So we measure once, right? We're going to say scale 1 shows a mass of 99.71. Scale 2 shows a mass of 99.72. Scale 3 shows a mass of 99.70, right? And maybe we do one more. Maybe we see scale 4 is 99.72 again. So these are 4 different devices, and they all show very similar measurements here. What we take from this is because our measurements are very similar to each other, in fact, instead of saying similar, I'm going to say very close. And in parentheses here, I'm going to say very little error between them, very little average error. And no, I'm not going to say error. I'm going to say very little, very small percent difference. And as a result of that fact, what we can say is that these are going to be precise. So if that's case 1, what does it look like when we're imprecise? And I want to be careful about this because it's possible for us to be accurate but not precise. So precise, us not being precise, in other words, us being imprecise, does not necessarily mean that the average of our values is incorrect. So let's say for this case, we're accurate but imprecise. Okay. Oh, that mouth. That didn't look right. That doesn't look right either. It's hard drawing emoticons on here. All right, a winky frown, that works. So we've got our 4 scales again. And here what we're going to see in our nice little contrived example is that the average of these is going to be pretty close, right? Maybe scale 1, what we get is 103.5. I started to write a 4. 103. Let's use the same precision or the same number of decimal places as we did above. 103.43. Maybe scale 2 is 101.20. Scale 3 is 96.17. And the last one is 99.92. So we've got these 4 different scales, and the average of this is actually pretty close to 100. I mean, it's not dead on, but it's pretty close. But, right, the spread of these 4 values is not good. And I'm actually going to say the spread and the standard deviation. And we're not going to worry about calculating things like standard deviations. That may be something that'll come up in lab, but it won't be something we'll worry about for lecture, I don't think. So we'll say that the spread and the standard deviation, both of these are going to be large. So that's case 2. Here we've seen that we're pretty accurate, but our precision is low. So accuracy, pretty good. But our precision in this case, in other words, the repeatability of our measurements across different scales, or worse yet, on the same scale, say you did the same measurement 4 times and got these 4 different numbers, right? What we would say here is that we're not being very precise. So our case 3 that we're going to talk about to illustrate precision and accuracy is, let's say that we're inaccurate and imprecise. Now, when we get to some visual examples involving things other than this sort of mass, this steel mass that we're talking about, you will see examples where we can be inaccurate but precise. You get the wrong answer every time, the same wrong answer every time, right? But let's talk about one last case for this, where we're both inaccurate and imprecise. So in this case, let's write our 4 scales. And I want you to think about what this is going to look like. So inaccurate means that we're not close to the true value. And imprecise means that we actually have a pretty wide spread. So this might look something like this. Scale 1 might say that it's 91.06. Scale 2 might say that it's actually 87.03. Right? We can see the average is now looking to be somewhere just south of 90. Okay, what about this last one? Maybe our average here is 92.97. And our very last one is 110.8, right? Our average here is not going to be very close. Actually, let me adjust that last one just to make this a little bit clearer. I'm going to make this even lower than our others. My apologies there. Let's correct this to 84. Because what I want to do is make it very clear that the average is nowhere near 100. So let's change this last one to 84.03 grams. What we can see here, right, the average is going to be less than 90 for sure. We also see that the spread of this is pretty wide, right? It goes from 84 all the way up to almost 93. That's a big spread compared to our first case where we're pretty precise, right? In this case, we saw that we had nearly 99.7 in each of these cases. So I'm actually going to add one little note up here. We're precise and fairly accurate. We're not exactly at right on 100, right? But we're reasonably close. So we can actually look at all of these and get a picture, I think, of accuracy and precision. But now, let's take a look at these in a less scientific context. Let me just save this one for us. Okay, so hopefully, if I open with this in private, it's not going to open my 1,000 windows I have open right now. There's 2 examples that I wanted to show you here. One of these is sort of the classical example. This is the one I saw when I was an undergrad, that we can talk, let's see, we'll find one of these that's a little bit bigger. We can talk about precision and accuracy pretty well by using a dartboard here, or using a little target that we can maybe shoot arrows at. If we look in the lower right-hand corner first, if all of these things are clustered right near the bullseye, and it's a really tight cluster, right, we're both accurate because we're hitting the bullseye, and we're precise because we're hitting it every time. Now, if you look just to the left of that, right, we've got high accuracy and low precision. We're still pretty close to the bullseye overall. Our accuracy is not bad. You know, we're not hitting this outermost white ring, but our spread is not perfect. We're not repeating that high accuracy bullseye shot every time. Now, we could also have something that's low accuracy and low precision. In this case, we're really not hitting the bullseye very well, right? We're kind of all over the map, and the spread is huge. So it's not exactly like we're very precise either. We're not repeating a measurement, or we're not repeating hitting the same place every time. Over here on the upper right, you'll see low accuracy and high precision. In other words, getting the wrong answer repeatedly over time, the same wrong answer. We keep hitting this bit right around like the 10 o'clock mark, right? But it's all in this tight cluster. It's almost like this is an expert marksman or marksperson shooting directly at that spot, right? We're hitting that same spot repeatedly, but we're doing it really precisely. Let's look at one more example of this. Another example I like of this is looking at the back of a basketball board. Now, I'm not exactly a sports person myself, but I think that this is another pretty good representation of this. Hope I can find it pretty easily here. I saw this just a couple of days ago. Maybe if I just search basketball. Yeah, perfect. This is the one I saw, and I really liked this one as well. So I will copy these and put them into our paint document there, so we can use them. Well, while that's figuring out what it's trying to do, let me open this image here, and we can at least start talking about this. So in the example all the way on the left here, it's low accuracy because we're always hitting the left side of the backboard here. But we're doing it pretty precisely because we're hitting the same part of the backboard every time. Now in the middle, we're not very accurate and we're not very precise. We're not getting any of the balls in the net, into the net, but we're also like hitting every part of the backboard. So we're all over the place and we're not being very accurate because we're not scoring at all. This one over here on the right though, this is high accuracy, high precision. This would be like your expert free thrower, where somebody can just be there on the free throw line and sinking every single one of these the same way every time. Right? They're both accurate because they're scoring every time, but they're very precise because they're hitting it in the same place on the backboard every time. That would be like your muscle memory really finely tuned in there. Okay. And right, we could use different sports metaphors here. If you think about it in terms of like a football field, right? If you're sitting there and you're trying to score a field goal, right? And you're kicking it between the gridiron every time. Good Lord, am I using the right term? That doesn't sound right. No, that's not what that thing is called. What's the football scoring thing? I'm not even going to cut this out. I'm not embarrassed about this at all. The goal post, good Lord, that's what it's called. That's where the phrase comes from. So if you imagine, right, that you're kicking it over the goal post every time and you're scoring a free throw every time, you're pretty accurate because you're making it through the goal post every time. But if you're missing widely, you're kicking into the bleachers on the side, you're kicking backwards on the field and you're losing distance, right? That would not be very accurate. But if you're at least getting it close to the end, to the goalpost every time, but maybe sometimes you're dinging it off of the left post there, or maybe it's landing all over the end zone, right? In this case, you're not being very precise. Even if you're getting it close to the goal here, you're not being very precise because your spread is really bad. So that's really what I want you to distinguish these two concepts as. Is one of these is talking about how close are you to what you're aiming towards, right? Highly accurate means that we're pretty close to the bullseye. Precision talks, however, about how big your spread is. So if we're talking less about these kinds of like visual examples and we're talking about stuff that you might see in your lab class, being very accurate means that if there is a correct value, correct meaning like you have a mass in front of you that you're holding in your hands, well, that thing has a certain amount of atoms, right? So whatever the actual mass of that thing is the quote-unquote true or correct value. But we may not be able to get that exactly accurately every time, right? So that's one thing that we want to think about is how close are we to the true value. And for precision, when you measure that, say you measure that on the same device repeatedly, is it giving you the same result every time? If you're measuring it on different devices, are they giving similar results between each other? Right? You can think of precision as being able to tell us more about the decimal places of something. If we measure it every time and the most of the error that we see is in like the 4th decimal place, like in this example here, right? We've got error that's probably in the 0.01 spot. But that 99.7 in this case is pretty precise because we've gotten that every time. It may not be exactly accurate because we're looking for 100, but the standard deviation of these 4 measurements in case 1 are going to be pretty similar. So I hope that this helps to clear up some of the ideas about accuracy and precision. Again, these can be terms that in everyday life, these are pretty interchangeable, the way that we use them. But in scientific contexts, and you might have heard me slipping up a few times in here, right? It's hard because we use these in everyday life pretty interchangeably. But in a scientific context, we need to try to get into the habit of using these two words to mean different things. So if you have any questions about this one, just let me know. My hope is that these different examples will hopefully make some more sense. I'm going to put these images here into the Paint documents so that you have these as well. And all of these will be uploaded onto Canvas. All right, thanks for watching.